Oh, the weather outside is frightful, but math is so delightful. And since you are required by law to be here today, let's do our sine functions. All right, so here we have f of x is equal to 2 multiplied by sine 2 times x minus 45 plus 1. So first thing that we could do is we could sketch on, we could say this is the line 1 here. We can set our scale as we like. So let's call that 1, that's 2, that's 3 up there. And 3 is going to be our maximum. It's right up there. And then there is minus 1 down there. And that's going to be our minimum values. Because this has an amplitude, an a value of 2. So it's going to go as much as 2 above the horizontal axis and 2 below the horizontal axis. Jackson, did I get yours handed in? Did you hand your test quiz in? Yeah? Okay, good. Okay, so we can sketch on this horizontal axis. It's going to be right here. Boop, 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 right along there at 1. Okay, where do we know that this horizontal axis is 1? Well, we know that from this number here. Wham! Okay, and then the k value is going to give us, so the c is 1, that gives us our horizontal axis. The k value of 2 gives us the period. So the period is equal to 360 divided by 2. So I know that this will go through one full cycle every 180 degrees. There we go. And it's shifted 45 degrees to the positive x direction. So normally this would start here and go up to 3, and it would usually go up every 90, but this is going to go up every 45, and then it was moved over. So this is going to, let's go ahead and evaluate what its y value intercept is going to be, and I think it's going to be pretty high there. So if I have 0 in there for x, and I can do my sketching down here, my rough work down here, f of x is equal to, what was it, 2 sine multiplied by 2, this is square bracket, x minus 45, bracket, plus 1. Let's put in this value 0 for x, and we'll see what that is. F at 0 is equal to 2 multiplied by sine of 2 times negative 45, so that's negative 90, plus 1. 2 times negative 45, negative 90. The sine of negative 90 is negative 1. So that's 2 times negative 1 is negative 2, plus 1 is negative 1. Okay. Sine negative 90, negative 1. It's 2 times negative 1, negative 2. Negative 2 plus 1, negative 1. Okay. Write it out, Mr. Jennings. The sine of negative 90 is negative 1. Your calculator tells you so. Evaluate that expression. It's negative 1. So let's go ahead and plot that on there. Boop. Okay, so this value that used to be on our curve, sine starts in the middle and it goes down this direction. That point over there was at negative 45. It's now been moved over here. Okay, so this is going to rise from here. And where is it going to hit this axis 1? Well, probably at 45. Let's see if it's going to be a value 1 there for 45. So if I put in 45 here, I have 45 minus 45 is 0. 2 times 0 is 0. 2 times the sine of 0 is also 0. Sine 0 is 0. Check it on your calculator. Or remember your angle in standard position at 0 degrees. It has an opposite side there of 0, so it's 0. Okay. Sine of 0 is 0. So 2 times 0 is 0. So this will be plus 1. So 45 gives me 1. So here we've found where it's crossing this axis there. I could also then say, well, I know its period is 180. So if I go up from 45 to 180 and then another 45, that's another spot where it crosses the axis. If I go backwards another 45, that's right there. That's another spot it crosses the axis. And then I could go back another 45, and that's another spot it crosses the axis. Okay, I got lots of spots where it crosses the axis. And then it hits a minimum there. It's going to cross the axis in between as well. There's going to be some spot over there where it's crossing the axis. Let's go find some of those. So if I want to find one over here where it crosses the axis, goes up, comes down, and then goes up, it's going to be in there. So let's test 135. Let's see what happens at 135. So 135, I'm going to input this. So f at 135 is equal to 2 multiplied by sine 2 times 135 minus 45. 135 minus 45 gives me 90. 2 times 90 is 180. So this is sine 180 plus 1. Okay. Sine of 180 is also 0. So this is 2 times 0 is 0. So f equals 1. So I can go ahead and put that one on there as well. So I'm getting some exact values there. That's great. And these exact values are nice for plotting my function. So I'm getting lots of points. And then, just by symmetry, I'm going to go ahead and put all those on there as well. I'm going to go backwards 180 degrees. So that's going to be, here's 0 minus 45 is right there. Okay. And then back another 180 degrees. So it's going to be 180 minus another 45. So that's there. Look at all those zeros that I'm getting to plot on there. Hi, how are you doing? Hi. Okay, put it right there. And then this one is going to be also 360 minus 45 is there. Thanks very much. Happy holidays. Right there. Okay, so I got lots of points there. Now let's see if I can find some of my maximums. So I want the values where this is 90 over here. So how can I get a 90 in there? I want this to equal 45, so that 2 times 45 gives me 90. So it looks like when x is 90, I'm going to have 90 minus 45 multiplied by 2. 90 minus 45 is 45. 45 times 2 is 90. So I've already got one of those there. There's my 45. Let's stretch. So that's wait. No, 90. 90 will do that. Yeah. So 90 gives me a maximum, and my maximum there is 3. So I can plot those on there too as well. So that's 3. So 90 gives a maximum. It's up there at 3. And then 180 degrees. So there's another one. And then back 100 degrees. So there's another one. Then back 180 degrees. So there's another one. I'm just using the period to do that. And then I'm ready to sketch this curve. So it's going to look like up, boom, down, and up, boom, down. So use the period to multiply your efforts. You don't need to find all the points individually. You can find them just by using the symmetry of the curve around 180 degrees. It's periodic. It's repetitive nature. There. So now, given these functions, state an equation with the specified parent function. First, locate the axis. Here's the axis. Visually, it's there. If I'm not sure, let's test. This should be the midpoint between the maximum and the minimum. The minimum value is 1. The maximum value is 5. So the average of 1 and 5 is 3. So there's the axis at y equals 3. The maximum value is 2 above the axis. So I already know my C value is 3. I know my A value is 2 because this has been stretched. And then I can look at the period. And let's see, here's the period from 15 to 135. So this is 120 long this way. So the period is 125. So, 120. Sorry. So 120 is equal to 360 divided by K. So I can use this to solve for K. K is equal to 360 over 120. K is also equal to 3. Okay, so I've got 1, 2, 3 of my numbers. And now let's find D. Normally, sine would start there because sine starts in the middle, and I've been asked to provide a sine function. So I want to take that point and move it. It's at 45. I want to move that positively by 45. So my D value is going to be equal to negative 45 because that's a sine flipper. There, I have my function. So it doesn't take very long. F of x is equal to 2 multiplied by sine 3. This is in brackets here. 3x minus 45 and bracket plus 3. Yeah.
Can you explain that D part again?
So D, I just did it visually for this one. I said, I know that sine normally starts here. Like my axis would normally be there. And then it would go up and come down, and then it goes down at 270 and then comes up to 360 there, right? 0 degrees, 90 degrees, 180, 270, 360. And so in order to take that start position and move it 45 points there in the positive direction, I need a d of negative 45. Okay? And so that is how I did that. There. That's how I knew to move this 45 degrees positively. And then you want to test some points just to make sure that this function is going to do the job. You're going to send people to the moon with that function, so you want to make sure it's correct. Oh, sorry, amplitude here was 2, period was 120, so that's how we derive our k. The axis was y equals 3, and the phase shift was 45 degrees rightwards. All right. So let's test a point. Let's test 75 because that's one of our maximum. We should get an output of 5 with this function. Okay, 75 minus 45, that's 30. Sine of, and then 3 times 30, that's 90. Sine 90 is indeed a maximum for sine. That's 1. So then I'd have 2 times 1 is 2. 2 plus 3 is 5. Great, that point checks out. Let's check this point. If we get the maximum and the minimum right, it should be right, especially since I'm confident that this k value is correct. So let's check 135. 135 minus 45 is 90, right? 3 times 90, 270. When sine of 270 is negative 1, great. So 2 times negative 1 is negative 2. Negative 2 plus 3 is 1. So this point checks out as well. So great, this is done. Final answer. It's not the only correct answer, but it is one of the correct answers. Some of you gave me 4 correct answers. Okay, here is a cosine function. And first thing I do is I find the axis. Visually, it's there. There's the axis. Mathematically, it goes up to 10. It goes down to negative 2. 10 plus negative 2 is 8. Half of 8 is 4. So that's how I know that's the axis. Y equals 4. Okay, the amplitude is given here or here. All right, it's 6 above the axis. So A is equal to 6. C is equal to 4. These are my transformations to get the function to match that. My period here goes going from negative 15 to 105. My period is again 120, so my k value is the same. It's 3. If the period's 120, then I needed to divide 360 by 3. That was my k value. If I look along 360 degrees, I would see 3 cycles of this function. Okay, so I've got k. Now I just need d. Okay, cosine usually starts at the top and goes down. So I could take this point and move it, I could take that point and say that I took this point and moved it that way. That would be fine. And so I would say my d value is equal to negative 105. Or I could have said, well, I took this point and I moved it back that way. So that would have been d is equal to positive 15. Both are correct. Both will give you a function that works. Here my function g of x equals my amplitude, 6, multiplied by cosine, square bracket, k, is 3, x plus 15, end bracket, and square bracket, plus the vertical axis 4, the horizontal axis 4. There's the function. If I test that, again, it's going to work because I know I'm right. Okay, that's how you do it. It's a whole quiz. There, break. Okay, everyone. So practice the delta math tonight to get ready for round 2. And take this one as a mulligan if you needed a mulligan. And yeah, we'll start with the project after the break.
Is it break now?
Yes, break now.